Hello guys, welcome to the new video. Today we are going to discuss, right? we in the previous lecture we discussed the problem solving with asymptotic notations. Right? We solved some problems in previous lecture. Now we will discuss here framework for analysis, right? Framework for analysis of algorithms. It is a framework for analysis of non-recursive algorithm, right? Non-recursive algorithm. So let's start asymptotic notations. What we if n is greater than log 2n is greater than log uh, n with base 10. So log 2 power 10 is 3.2, log 10 is 1 only. So this is the example, and second log n, when log 10 would length log n, this is log 2. So greater than log n, this is 1. 1 by log n is what? 3. This is greater than this, right? So GR is big O of Fa. Alright. The time complexity of recursive algorithm is derived and represented as a recursive equation. Alright. If the time complexity of algorithm, if the algorithm is recursive, then the time complexity of that algorithm is also represented as recursive equation. Alright. It's a mathematical model or solve recurrence to get the value of recurrence as a mathematical function like polynomial, log, exponential, or constant. All right, then we can apply the ASNs. All right. So first we have to represent the time complexity and recursion function. Then we will solve that recurrence, get a value in mathematical function. All right. Then we will apply the asymptotic notations. All right. So solving recurrence has have three methods. First is bracket substitution method. This is a universal method, repeated substitution. This is master method is shortcut. Recursion tree, alright. Third method is recursion tree, and second is master method. It's a shortcut method. We can directly if equation satisfy certain conditions, so we can directly give the answer, alright. And this is the back substitution is a universal method which can um, solve as repeated substitution. So time complexity framework for recursive algorithms. All right. So algorithm, what n? Let's say this is an algorithm. What n? So if n is equal to 1, then return. Else, what n minus 1? Bn. All right. So this is a function. All right. This is a tail function. We can see tail function. Right. So assume Bn is order of 1. All right. Let Tn represent time complexity of what n. So Tn is equal to C if n is equal to 1, because here is a constant will be. So if C is greater than 0, alright. So if there is only one input, then it will return from here and only, alright. Else it will call what, let's say this is A time, this comparison takes A time, and T of n minus 1 times take this n minus 1 function, and B time this B function takes, alright. A is greater than 0 and B is greater than 0, alright. So Tn is equal to Tn Tn is equal to A plus Tn minus 1 plus B, and then Tn is equal to Tn minus 1 plus D, where n is greater than 1, right. D is equal to A plus B is greater than 0, right. So assume Bn is equal to O of n, Tn is equal to C, n is equal to 1. So now we will assume this is the recursive function here, alright. If Bn is order of 1, if Bn is order of n, then if n is equal to 1, Tn is equal to C, else it is A plus Tn minus 1 plus n, alright. So or else we can assume that Bn is a function which has the time complexity of order of 1 by n. So this will be the equation for n is greater than 1, alright. So in this case, let's first we do the back substitution method. Back substitution method we apply here. So let's say Tn is equal to, let's do here is Tn is equal to Tn minus 1 plus D. So for Tn minus 1, what it would be? It would be Tn minus 2 plus D, alright, and plus D. So for Tn minus 2, it would be Tn minus 3, what say, plus D only. If we substitute this equation in this, alright, what it could be? Tn minus 1 will become Tn minus 2, Tn minus 3, I mean 3 plus D plus D. If we substitute this equation in this, then it will become Tn is equal to what? Tn minus 3 plus D plus D plus D is equal to, we can say, Tn minus 3 plus 3D. As we will go for, if we generalize this, Tn minus K plus Kd, if n minus K is equal to 1, then what? Then K is equal to n minus 1, alright. So it will become T of 1 plus n minus 1 into D, alright. So T of 1 is 1, alright, 1 plus nd minus D, it will become order of n, alright. So how does we do done that K is equal to D, T1 KD, then D of n minus 1, this is C here, C is a constant and equal to 1 for equal to 1. Now let's see the order of n and big omega of n. So this is theta of n, the solution value of recurrence. Alright. So this is how we do that. Alright. This is second. If the if the question order of function bn is order of n, so we will be here adding a n here, then for n minus 1 here, and again if tn minus 1, we substitute that, this will become tn minus 2 plus a plus n minus 1 plus a, then 2a plus n, and so on. We can do that tn minus k plus tn minus k minus 1, then tn minus 1 plus n plus ka. Alright. So if it will become 1 here, if n minus k is equal to 1, then n minus k is equal to 1, then k is equal to n minus 1. So we substitute that from here. What will become c plus 2 plus 3 plus 4 plus dot dot n and a plus n minus 1 here. So if c is, let c is equal to 1, and it will become n plus 1 by 2 series, right? This, then an plus n, this will become that n plus 1 by 2, and an minus a will become order of n square. Alright. So omega of n square. So it will become theta of n square. So we do this. Right. This is how we do back substitution. If the function was 1 by n, then 1 by n minus 1 and again, and so n minus k minus 1 plus n. This is 1 by 2 plus, this is a harmonic series, I think. So let's see equal to 1, then n minus a. This will become log n. Again, it will become order of n here. Alright. So you can say also here. Time complexity framework for recursive algorithms. Alright. Algorithm do it now here. So what we done here, that let's say if n is equal to 1, then return, else return what? So do it n minus 1 plus do it n minus 1. This is 2 n minus 1 are here plus d. So if the function is in the form of tr is equal to 2 n minus 1 plus d, right? If we say tn minus 1 again, then what? 2t n minus 2 plus d. We substitute it here, then what will we get is tn is equal to 2 into tn minus 2 plus d plus d here. What it would be that 2t n minus 2 here, 4t n minus 2 plus 2d plus d. Alright. That it is, yes, this d. Right. What would become 2 to the power 2 tn minus 2 plus 3d, right? So if it is n, so n minus k, then for this 2 to the power k, right? t n minus k plus 1 d. Alright, this is the case here. Now, how can we solve that? Tn is a function, k is equal to 1. If n minus k is equal to 1, then k is equal to minus 1. 2 to the power n minus 1 is equal to become plus n minus 1 plus 1 into d is equal to 2 power n minus 1 plus and d. What it would be that 1 by 2 to the power n plus and d. Let's say to the power order of 2 to the power n. And or what one is, we can say that so omega of 2 to the power n also. Alright, because bigger than always order of in the order of that. So theta of 2 to the power n. Right. So how we'll do that? That is 3d we have 2 square minus 1 d here k minus 1. Alright. So this is also how we do this. K minus 1. This is the way we do that. And e into 2 power n minus d. Right. So this is theta of 2 This is how we done that. What the mistake I was doing in this case. Right. So right. If I fail, let's say there is an algorithm for what algorithm for AN. If n is equal to 2 return as return a square root of n. Right? Algorithm AN if n is equal to the return as return a square root of n. So how do we do that? Let's discuss this also. Oh, so how do we do that? Let's see. Let's say this is Tn, right? Is going to be T of square root of L, right? Right? Or we can say T of N by 2, if we can get a mass first time. No, but for what we can do this? Because here it will decrease in root times, alright? So it will become T of N by 1 by 4, right? If T is N1 by. So from this, how can I do that? That substitute this, that T is equal to what? plus a thing, I'll think. Plus age here also. Plus age here. So what it could be? The value is t of y4 plus 2a plus 2a. So if power 1 by 2 power k, right, is equal to ka. So what we will do is that ny power k is equal to 1. So how should we do that? That log, we take log 1 by 2 k. Log 1 is 0, but we can't say take log here. What we can do here, but so base case is 2 here. So we will take 2, right? So we now we can take log. So log 1 by 2 calculate log equal to 1, right? Log n to power k and k is equal to, we can be log k is equal to log n, right? So this is will become 1 or 2, I think. 2 is 1, I think. So plus log n 3 times. So this is time complexity of log n, right? Order of log n. 2 I this one is 2 here, so 2 really gets here. Alright, so we will take it to this important question. If I Q it is equal to 2 marks, right? Alright, so now we have to framework for recursive. This is also PYQ for 2 marks. This is the also. So let's see. 2 here also. 2 into, this is the 2 into here. This is to our k, t k plus k minus 1 into 2. This is the case as we built up. So how do we do that? We will log n here. So our log n, right? So it would become that what it will become log of, right, log n to the power log 2, right, plus to the power log n 1 into the, so it will become log n only plus it will also become log n only, row for row log n. This is how we do that. Log 2 log 2 log n log 2 2, right? So we become order of log n here, I think. It will become order of log n, So the answer, this is 4 of log n is. This is the answer. Right? Now what? Again, some questions are here. This is also a question that Tn is equal to 2, if n is equal to 2, and otherwise it is the question. So let's discuss this separately. Right? First, we'll draw the pen in different. Right. So how we do that? If is it done from here? No. What is Tn equal to if n is equal to 2, else square root of n t root of n less than 2. So let's say this is the equation here, right? The equation is that Tn is equal to, what is it in 2 or right? And power 1 by 2 t to 1 by 2 plus n, right? If we go Tn 1 by 2 and 1 by 4 plus n2 t of n 1 by 4 plus n, right? Right. If we substitute it from in this, so we get what? N of 1 by 2 into n of 1 by 4 t n over 1 by 4 plus n plus n. If we solve this again, so it would be our 1 by what? 1 by 2 plus 1 by 4, 4, 3 by 4, 3 by 4, t n 1 by 4 plus is this. This is also like this. So here is 1 by 2. This is 1 by 2, right? So 1 by 2 plus 1 by 2 is 1 of 1 and 2n, right? So what is this, that how we can do that? 1 minus 1 by 4, 4 minus 1, also we can write. So 1 to the power 1 minus 1 upon 2 square, right? Plus t power 1 by 2 square plus 2n, right? So how what we can write, and 1 minus k square, right? Or is it 2 to the power k? So it is 2 to the power k, I think, t n upon 2 to the power k plus 2, I mean kn, right? So now we discuss the thing, n by 1 upon 2 to the power k equal to 2, right? So what we can do, that log, take log 1 by 2k log n is equal to 1 log n equal to the power k, right? Equal to log n, right? So what would we go do this? and 1 minus 1 over log log n log n, right, plus k n dot log n, right. So what is it could be that could be solved like log n or 1 minus 1 upon log n. So 1 into our n minus 1 upon log n plus n log n, I think, over log n. What is the order of this? Now I have forgotten that. Okay, then order 1 upon. So it is solved here only, right? It was n, I think. Is it n? 2. So it was solved here. Log n, log 2 log n. What it was the 1 by 2 hour log n. So what it could be that? बचेगा ही तो है वो 2 hour log of log n, right? So what could we do here? Could be here that log n here, log n to the power log 2 to the 1. So it will become n power 1 by log n. Right? What it could become then? It will become n log 2 base n, right? It would become 2 log n and it will become 2 only, right? So this is how it will become 2. So n plus n dot log n. So this is the time complexity, right? N dot log n. I think I was right there also. So this is the case, I think. So if I calculation is n by 2 thing. So this is 2 of t n by 2. 2 of t n by 2 plus t by 4 by 3. 5 over of n. This is a simple one, I think. 5 over of is bigger than log n, right? So do it and we will do it and y2 be n 1 log n, right? Right. So big O of n, big O of n what? It will become O of n. How we do that? Just let's see. Right. Is equal to T of n by 2 plus n. Is this, let's say, all right is the thing. T of n by 2 n by 4 plus n. If we do that, what will become that? T of n by 4 plus 2n, right? T of n by 2 over k plus k, k is equal to 1 over k, log n is equal to k, and log n, right? Alright, so this is not how it works. So say n by 2 here. Alright, if you go for T of n by 4, it will become 16. T of by 8 is n by 4. So we substitute 4 in this. So what will we get? We will get that T of n by 2 power 3 plus y to the power 2 plus power 1. Right? And we substitute this also here, there. So then we will get 3 0. So what will become that if T of y or k plus or 1 or k minus 2 is n by 2 or 0. K is equal to log n here and plus 2 or minus 1. And what will become that 1 by 2 plus 1 by 4 plus 1 by 8 dot or 4 log n minus 1. Is it the same? So let it be k, right? So become this is c, then c plus and sigma I is equal to 0 to how much? K minus 1 upon to the power I. Say harmonic 1 then S1 is equal to A 1 minus R2 over M jar. A is what? 1 by 2 I think here. 1 by 2. 1 minus R what? 1 by 2 over K minus 1. 1 by 2. This would be into 1 minus 1 by 2 K minus 1. So log n minus under log n minus 1. How does I solve? Which is our K 2 minus 2n on 2 over log n and only and minus 2 over minus 2 2 is no how it's 2 kind 2 and how to the the given diagram represents a plot of the cursive indicating all the statements except the for the recursive calls have order 1. Then the base case or the worst case of the term complexity. Worst case 1, 2, 3, 4, 5, 6, 7, 8. Let's see. Best case start a yes 2, 2, 2 over n. What is the worst case? Let's see what is the worst case later. Thank you so much for watching the video. We'll meet you guys in the next one.